All right, now let's look at number 16. Solve 4 and 1/2 divided by 1 and 1/3. See how it's written like this. I know it would be nicer if it looked like this. 4 and 1/2 divided by 1 and 1/3. We always want to show our work because otherwise we'll make mistakes. Okay, these are easy to screw up if you try to do them mentally. But when I rewrite it like this on paper, now it's going to be a lot easier to change these into improper fractions. And whenever you're working with multiplying or dividing of fractions or mixed numbers, um, you need to change your mixed numbers into improper fractions. So going around the horn, 2 times 4 is 8. 8 plus 1 is 9 over that denominator of 2. Divided by, do the same thing here. 3 times 1 is 3. Add 1, that's 4. We put that over our denominator of 3. Now, you don't ever actually divide fractions. What you're going to do is rewrite it as a multiplication problem. So we're going to write 9 over 2 times, and then you write the reciprocal of 4/3, which is 3/4. We multiply by the reciprocal. Dividing fractions is the same as multiplying by its reciprocal. Some people will say, drop this value, flip the fraction, and then switch from dividing to multiplying, drop, flip, switch, drop, flip, switch. It sounds all fancy and clever. I would just rather just say I'm going to multiply by the reciprocal of that second fraction. Now that I have rewritten it like this, I can't simplify anything. See, up here it looked like I'd be able to simplify the 2 into the 4, the 3 into the 9, but you can't do any simplifying until it is written in multiplication mode. Okay, so all I can do now is multiply. 9 times 3 is 27 over 2 times 4, which is 8. And that's my answer. I just have to change it back to a mixed number by dividing, because remember, the fraction bar always means divide. So 27 divided by 8. 8 times 3 is 24. Subtract, we get a remainder of 3. The remainder goes over the divisor. So we have 3 and 3/8. That's the answer to this problem. All right, in number 17, Mark lives on a block with house numbers from 30 to 62. If everyone on the block has a prime number for their house number, how many houses are on the block? Remember, prime numbers are the ones that only have two factors, one in itself, nothing else goes into them. So really, the only number that's even that would be prime is the number 2, right? All other even numbers are composite. So when you're looking at these numbers from 30 to 62, we don't even need to look at the even numbers. We know those won't be prime. So let's just look at the odd numbers. So we have 31, 33, 35, 37, 39. I'll just list them out, 30s, then I'll do 40s here. 41, 43, 45, 47, 49. Then I'll list the 50s. 51, 53, 55, 57, 59. And then we only have one more, 61, because once you get to 63, well, now you're larger than 62. You're not in this range of numbers here. So now you do want to write these down, because now what you can do is you can eliminate any of these numbers that are prime. Okay? I'm sorry, you want to eliminate any numbers that are not prime, because it says here if everyone on the block has a prime number for their house number. So let's circle the ones that are prime, because those are the house numbers are all prime. 31 is prime. The only numbers that go into it are 31 and 1. Nothing else will divide nicely into it. Now 33 is composite, because guess what? 3 goes into it 11 times. So I'll get rid of that one. 35 is composite. Anything that ends in a 5 can be divided by 5. 5 times 7 is 35. 37, now that one's prime. 39, oh boy, 3 goes into it 13 times. So that's not good. We're only looking for the prime numbers. 41, that's prime. 43 is prime also. 45 ends in a 5, so it's not prime. 5 goes into it 9 times. 15 does 3 times as well. 47, now that's prime. 49, is that prime? Nope. 7 goes into it. So that's out. Now here's where it starts getting a little tricky. See, 51, guess what? 5 plus 1 is 6. 3 goes into 6 2 times. This is composite. 3 times 17 is 51, so we need to eliminate that one. 53, though, that's prime. 55, that's not prime because 5 goes into it 11 times. 57, be careful. 57 is also not prime because 5 plus 7 is 12. Doesn't 3 go into 12? So 3 goes into 57. 19 times to be exact. 3 times 19 is 57. So that is composite. We get rid of it. 59, though, that's prime. And guess what? 61 is also prime. So how many houses are on the block if everyone on the block has a prime number for their house number? Well, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 houses on the block. All right, number 18. Which ordered pair would be on the graph of y equals 10x plus 6? When you're looking at ordered pairs, your first number is x, the second number is y. So basically what you want to see happen is if you substitute the x value in 6, 0, 5, or 5, substitute it in for x, take it times 10, add 6, and see if you get the value you have for y. And I'm actually going to start at the bottom here because I'm noticing both of these have an x value of 5. So that makes me kind of suspicious if one of those might not be the correct answer. And then would the y value end up being 55 or would it end up being 56? Let's see what happens. So y equals 10x. That's 10 times x. So let's try 10 times 5. Because in both of those, 5 is your x value. So we're substituting that in for x plus 6. So y equals 10 times 5 is 50 plus 6. So y equals 56. Oh my. Is either one of these, does either one of these have a 56 in your y position? Yeah. That one right there. So when x is 5, y does end up equaling 56. This is your answer right here. It won't be any of these. You could try all of those out, putting 6 in for x and putting 16 in for y and testing them to see if they work. None of the others will work. All right, number 21, we have 2.36 liters and we want to convert that into milliliters. And this is where it's helpful to remember kids have dropped over dead converting metrics. Kids have dropped dead converting metrics. Kids have dropped over dead converting metrics. Don't worry. I have never seen anybody drop over dead converting metrics. But here's what that helps us remember. Kids starts with K, just like kiloliters. Have starts with H, just like hectoliters. Dropped, now that's decaliters, D-A-L. Over, that's where we put liters. Dead, that's the other D, that's deciliters. Converting, that's your C, centiliters. Metrics, that's your M for milliliters. So if I have 2.36 liters, I'm starting here at liters. And I want to convert it over to milliliters over here. I need to move 1, 2, 3 spaces. And I'm moving it to the right when I'm moving from liters to milliliters. So what that means is I'm going to move the decimal point 3 spaces to the right. 1, 2, oh, that gets me past the 6. But have I gone 3 spaces yet? Nope. I have to go one more space. 3. And in this space, I fill in a 0, and I have 2,360 milliliters. Okay? That's how you make conversions in the metric system. By the way, if this had been grams or if it had been meters, it would work the same thing, same way. You would just have kilometers or kilograms instead of kiloliters, but the scale looks exactly the same. All right, and then number 22. This is the last one I'm going to show you from today's review. What percent of 220 is 65? You know, you could translate this into words. What percent, P, of 220? See, in math, of means times. So times 220 is 65. In math, is means equals. And then to solve this, you can divide by 220. Divide by 220. So P equals 65 divided by 220. This is where having a calculator will be very helpful. So I'm going to take 65 divided by 220. It's the top number divided by the bottom. And that equals 0.295454 and on and on and on and on forever. Now that's your decimal value. To convert it to a percent, you move your decimal point right 2 spaces and we get 29.545454 ... percent. Okay, so to the nearest hundredth, that'd be 29.55%. Okay, to the nearest tenth, it would be just 29.5%. Okay, so depending how you're asked to round it, I believe in this one it has 29.55%. It has it to the nearest hundredth. Okay, that's it for today. I will see you tomorrow.